The strangest thing about the semiconductor industry is this. Hold one of these things between your fingers and it feels like nothing. A sliver of grey-black material, smaller than a fingernail, lighter than a coin. Drop it and you'd probably never find it again on a carpet. Sell it on its own, and depending on what kind of chip it is, you might get a few dollars, sometimes less. And yet, somewhere right now a smartphone is lighting up in someone's hand. A car is starting in a driveway. A laptop is waking from sleep. In a data center you'll never see, in a building with no windows, millions of requests are being processed every second. Somewhere, an AI model is generating an answer to a question a person just typed. All of it, every bit of it, depends on something almost invisible, a piece of silicon smaller than your fingernail. Inside that sliver, engineers have packed billions of transistors, not thousands, not millions, billions. Switches so small you couldn't see a single one without a microscope powerful enough to make your head hurt just thinking about it. You can hold a chip between two fingers, but behind that tiny piece of silicon is an industry measured in billions of dollars. So here's the question that doesn't make sense on the surface. If the object itself is so small, so cheap to hold, so easy to lose in a couch cushion, where does all the money actually come from? Stick around, because the answer isn't what most people assume, and once you see it, you'll never look at your phone the same way again. Let's start with the first misconception, because almost everyone gets this wrong. People assume a semiconductor company makes a tiny piece of silicon and sells it for an outrageous markup. Simple business. Cheap material, expensive sticker price, huge profit. That's not really what's happening. The economics of a chip don't begin at the factory. They begin years earlier, in rooms full of engineers who haven't built anything physical yet. Someone has to design the architecture, the actual blueprint for how the chip will think, how it will move information, how it will do its job. Someone has to develop the underlying technology that makes that design possible in the first place. Someone has to build the software tools just to design the chip, because a modern processor is too complex to draw by hand. Someone has to manufacture the wafer. Someone has to test it. Someone has to package it so it can survive being installed in a real device. And someone has to move it through a supply chain that might stretch across 3 or 4 continents before it ever reaches you. Design, manufacturing, equipment, materials, packaging, software, intellectual property. Each one of those is its own world, its own set of companies, its own decades of specialized knowledge. The chip is the product, but the semiconductor industry is the machine that creates the product. And here's where it gets strange. One single part of that machine, just one piece of the process, can cost more to build than an entire skyscraper. Let's go there. Picture an advanced chip factory, not a warehouse with workers on an assembly line, something closer to a cross between a laboratory, a supercomputer, and a hospital operating room, except it spans the size of several football fields. Modern chip manufacturing requires environments so clean that a single speck of dust, invisible to your eye, can ruin an entire batch of chips. The air inside these facilities is filtered more aggressively than in most hospital surgical rooms. Workers wear full body suits, not for their own protection, but for the chips. A stray hair, a flake of skin, a breath in the wrong direction, any of it can introduce a defect that ruins thousands of dollars of material. Inside, you'll find machines that etch patterns onto silicon using light precise enough to draw lines thinner than a strand of DNA. You'll find systems that deposit materials one atomic layer at a time. You'll find water purification systems more advanced than most municipal water plants, because even trace minerals in the water can contaminate a wafer. This isn't a factory where someone grabs a wrench and builds a chip. It's closer to a laboratory, a computer system, and a factory, all operating at once, all day, every day. Building one of these facilities requires an amount of capital that's genuinely hard to picture, and running it requires a level of precision that leaves almost no room for error. Here's the twist most people never learn. Not every semiconductor company owns one of these factories. In fact, some of the biggest names in chips have never built a single wafer themselves. This is the split that runs through the entire industry, the line between fabless chip designers and foundry manufacturers. A fabless company designs chips but pays someone else to physically build them. A foundry does the opposite. It doesn't design its own chip product, but it manufactures chips designed by other companies, sometimes dozens of different customers at once. It sounds almost backwards. The company whose name is on the box may never have touched the silicon. So let's talk about design, because this is where a huge amount of the value actually lives. A fabless chip company can spend years, sometimes the better part of a decade, developing a single processor architecture. Teams of engineers, endless testing, countless failed versions that never make it to market. All of that effort goes into something you'll never see directly, because what eventually reaches you is just the finished chip, sitting quietly inside a device. The final object is tiny. The intellectual property behind it is not. You're not really paying for the silicon. You're paying for everything humanity had to figure out before the silicon could exist. But here's the catch. Even the smartest design in the world is worthless without a machine capable of turning it into something real. Which brings us to a layer of this industry most people have never even heard of. The companies that build the machines that build the chips. Inside every advanced chip factory sits equipment so specialized that only a handful of companies on Earth know how to make it. Machines for lithography, which etch the design onto the silicon. Machines for deposition, which lay down materials in impossibly thin layers. Machines for etching, for inspection, for measuring dimensions smaller than a virus. Machines for packaging the finished chip. Machines for testing whether it actually works. A chip factory, for all its scale and cost, is itself dependent on an entirely separate ecosystem of specialized companies. And that's when the real shape of the industry starts to come into focus. The chip industry isn't one industry. It's an entire chain of industries stacked on top of each other. Some of the most strategically important technology companies in the world aren't the ones whose logo ends up on your laptop. They're the ones who make the machines that make the machines that make the chip. Companies most consumers have never heard of, quietly holding a kind of leverage that's hard to overstate. And the deeper you go into this chain, the smaller the number of companies capable of doing each step becomes. Why does that matter? Because it explains something that trips people up constantly. Why the most advanced chips are so hard to replace, and why they don't lose their value the way a normal manufactured product would. Building the most advanced chip-making capability on the planet isn't something a new company can just decide to do. It requires years of accumulated research. Specialized talent that took decades to train, enormous, sustained capital investment, a web of suppliers who have to trust and qualify each other, manufacturing knowledge passed down through thousands of small, hard-won lessons, the kind you can't just read in a manual, because a lot of it was learned by making mistakes that cost millions of dollars. A company can't wake up one day and say, "Let's build the world's most advanced chip factory." The expertise, the equipment, the suppliers, the workforce, all of it takes years, sometimes over a decade, to build from scratch. That difficulty is the moat. It's the wall around the business. The real secret isn't that the chip is expensive. It's that almost nobody on Earth can make the most advanced versions of it. Now let's zoom out to right now, to this moment, because something has shifted the value of these chips in a way that's reshaping the entire industry. Artificial intelligence runs on computation, massive amounts of it. Training a large AI system means running enormous calculations across thousands of processors, working together for days or weeks at a time. Once that system is built, using it, what's called inference, still requires significant computing power, multiplied across however many people are using it at once. This has put an intense amount of attention on high-performance semiconductors, the kind built specifically to handle these workloads. Demand for this category of chip has grown quickly as companies race to build out AI infrastructure. But here's the part that matters for understanding where the money actually comes from. A chip built for AI computing doesn't operate alone. It sits inside a server. That server sits inside a rack, connected to networking equipment, cooling systems, power delivery, and storage. That rack sits inside a data center the size of a small town. And all of that infrastructure runs on software written specifically to make use of the chip's capabilities. The semiconductor business doesn't end when the chip leaves the factory. It continues inside the machines that depend on it. That one small object becomes the anchor for an entire tower of infrastructure built around it. Now bring it back down to something more familiar. Your car. Modern vehicles are, in a very real sense, computers you happen to sit inside. Semiconductors manage the engine. They run safety systems, from anti-lock brakes to collision detection. They power the infotainment screen, the sensors, the driver assistance features that quietly correct your steering or apply the brakes before you even notice a problem. Electric vehicles depend even more heavily on chips to manage the battery and control the power flowing through the entire car. None of this is limited to cars and phones. Industrial machinery runs on semiconductors. Medical equipment does too. Telecommunications networks, data centers, home appliances, factory robotics. The list keeps going, and it keeps growing. Here's the realization worth sitting with for a second. We don't buy semiconductors. We buy products that are impossible without them. Nobody walks into a store asking for a chip, but almost nothing on the shelves would exist without one hiding inside it. That's the hidden economic engine. Not one purchase, but millions of purchases across nearly every category of product, all quietly funneling value back through that same long chain of design, manufacturing, and equipment. Now think about how that chain is physically distributed around the world, because this is where the story gets genuinely strange. The engineers who design a chip might be in one country. The specialized equipment used to manufacture it might come from another. The raw materials might be sourced from a third. The wafer itself might be manufactured somewhere else entirely. Packaging and testing might happen in yet another location. And the finished product might ship to customers on every continent. No single country, and often no single company, controls the entire chain from start to finish. That's not a flaw in the system. It's the system. Decades of specialization, each region and each company focusing on the piece it does best, created an interconnected web that's extraordinarily efficient and extraordinarily complex. A disruption in one small link, thousands of miles from where you're sitting, can ripple all the way down to a device on a shelf near you. The smallest object in your phone may have traveled through a supply chain that spans the entire planet before it ever reached your pocket. So, let's finally answer the question we started with. Where does the money actually come from if the physical object costs so little? It doesn't come from the size of the chip. It never did. It comes from the design work poured into it before it existed. It comes from intellectual property built up over years, sometimes decades. It comes from manufacturing capability that almost nobody else on Earth can replicate. It comes from scarce, hard-to-build capacity, and from equipment so advanced that only a handful of companies know how to produce it. It comes from engineering talent, from the software layered on top of the hardware, and from the sheer scale of global demand pulling all of it forward. Different companies capture value at different points along this chain. Some specialize purely in design. Some focus entirely on manufacturing. Some build the equipment that makes manufacturing possible. Some write the software that makes the chip usable. Some handle materials. Some specialize in the packaging and testing that happens after the silicon is made. And some build entire ecosystems of hardware and software around a single chip family, locking customers into their platform for years. The semiconductor industry doesn't sell tiny pieces of silicon. It sells decades of knowledge, compressed into something smaller than your fingernail. So picture that same chip again, the one from the very beginning, sitting between two fingers, looking like almost nothing. Except now you know what's actually inside it. Billions of transistors, arranged with a level of precision that took decades to achieve. Years of engineering that never shows up on the surface. Factories that cost more than the buildings around them. Machines built by companies most people will never hear of. A supply chain stretched across the entire globe. Thousands of people, across dozens of companies, all contributing a small piece to something that fits in your palm. The chip may cost pennies, or dollars, or something in between, depending on what kind of chip it is and who's buying it. But the real value was never the piece of silicon itself. It's everything that had to happen before that piece of silicon could exist. And that's how something smaller than your fingernail became the foundation of one of the most powerful businesses on Earth. If you want us to expose the hidden business behind another everyday technology, subscribe. And tell us in the comments which industry you want us to investigate next.